All right, I'm gonna go over in depth about how each of these mechanics work in here. All right, so we're just gonna start with the widgets really. So the HUD overall is a widget switcher. Gets the player controller, sets it the UI mode, makes it so you can see the mouse, and then sets up all the parent widgets. It initializes the mouse part because the first widget here is the start widget, so I want to be able to see the mouse. And then this little function is called every time a widget switches, so that it will tell if it's like the game interface or not. So if it is the game, I don't want it to have a mouse. If it's not the game, then it will have the cursor on it. That's basically all this does. So when you hit start, it takes you to the song menu, which is very simple. It's either you're gonna click it and start the game, or you're gonna go back. So we're gonna start the game. It goes to the game mode. It does pick, for now, you know, I don't have a whole data table setting up all the songs and whatnot, but it just gets a random int for how long I want the song to be, and it'll take us to the game mode. So I double clicked it, took us to the game mode. This is where it starts, right? It does at the very start of the game get a call to the spawner. It sets that because we will be needing that throughout the whole gameplay, right? That's where we spawn the things at. So the start of the game, it's gonna check what loop we're on and how many the max loops are. And if we're underneath the maximum amount, we're gonna continue on, right? And we're gonna spawn a note. And this is gonna happen anywhere between 0 and 3. Because back on the demo map, there are 1, 2, 3, 4 lanes to spawn here, right? So depending on what int it is, it'll spawn in one of those lanes. It'll add the loop. It'll add the note to the array so we don't forget where the note's at. And then it spaces it out by however BPM the song is, which if down the line I wanted to expand on this, I could easily plug this into a data table. And then it is going to loop back the gameplay, and this will continue until the end of the song. Then we have a couple of checks that are going to happen. So first of all, it's going to see if we're on the last note or not. That's what this is checking. So if we're not on the last note, we're going to loop back around and check again in one more beat until we are on that last note. Then if we are, we're going to see if it's valid or not. So this is specifically checking if that last note is on the screen or not. Because if we were just checking if it was 0, that note will be on the screen and it'll just end. We have to see if it's still there or not. And if it's not there, that is when we will continue and finish the game. And the player pawn controls that because he's the guy who initially spawns in the HUD. He is also the guy that controls the input with the controller. And that is how we connect back to the finished game function, and it takes us back to the widgets, which in the end we can either play again or quit. Simple code again, we can quit or we can play again. It takes us back to the widget index, which takes us back to the HUD, so then we can play again as much as we want. So that's it for the widgets and the base gameplay. When it comes to how the scoring system works, it's a bit more complex. So we will start with the spawner. Spawner is very simple. It just has the locations. That's all it is. It's a location array. 0, 1, 2, 3. Just like the same 4 that matches up with each of these lanes going on here. That's basically the same thing here in the goal. We just have goals, 1, 2, 3. And that matches. They start out all the way up there, and then they come down here and they end over here. That is like the progression that they make down the lane. That's all they do. Then as they come down, you see these colorful little boxes. I have them color coded for my own sanity. That is where our little scoring mechanic comes in. So these are all collision boxes. If I zoom in, these are all collision boxes, and there's probably a more efficient way to do this. There's probably a way to do this all with widgets, but this is like a 3D map for no particular reason. So this black box over here is a kill collision. So my auto kills up there. Whoops, that's supposed to be a miss one. But anyway, it'll know you miss if you hit it up here. You won't get any points if you miss up here. Then the closer you get, like this first box is the good color, which is red because that's not the best score you can get. The second one is yellow. Oh wait, no, it goes okay, then it goes good, then it goes great. This blue one in the middle is perfect, then it goes great again, and then good, and then okay. And then this is the miss volume. So once the end of the box hits this, it's a miss. And then this purple volume right here is the auto kill. So if you don't hit the note at all, it just goes to the end. It'll die once it reaches this goal actor here, basically. So that's how that works. So all the scoring mechanics are very similar. It just basically checks like which one of the notes is overlapping it, and then it connects to the note and it will update its score based on an enum I made. The enum is very simple. It just basically holds which value it is. Miss, okay, good, great, perfect. But inside of the note is where some math happens. So we get the goal actor, we get the index, and that's how we get the goal location. That's how we get and the starting location, because this happens on begin play. So right when it spawns in, that's where it gets its origin location. Then we set the play rate for how fast we want the notes to go by, which this would be adjustable if we had more songs, more data tables, and whatnot. And this timeline will update us from the origin to the goal based on our play rate, and it'll update the actor's location. And then, depending on when you hit the note, it'll call this kill function based on whatever the score enum is set based on when it hits those colliders. It'll add the score based on the enum, and if you like miss it and there's no score, it just removes it. It doesn't do any score function here, and then it destroys the actor. So in the game mode, we went over the whole looping part here. I don't think I went over this part. This is the add score function. We get the quality, and then it changes based on the enum. The score gets added. If it's a miss, there's 0 points. Okay is 1, good is 2, great is 5, perfect is 10, and then it updates the score accordingly. I think I already went over to player pawn. That's what spawns in the HUD and make sure that the inputs actually work. We went over the scoring one, went over spawning, enum. This blueprint function is just a fast way to get the player character. That's all that does. Not very important. We went over the game mode. We haven't gone over the controller yet. So at the beginning, I have a camera actor in the scene up here. This is where I want the player to see, and I set the perspective smaller because ideally this would be a phone game, but right now it's just working on PC. So that's what this little beginning part's doing, is setting how I see it, and then it sets the game mode as a variable. And then down here is where the inputs happen. So I have all the inputs linked to one input action. So the keys 1, 2, 3, 4 all go through this action event. And I have those keys stored in this little array here. So based on what key we're hitting, we're gonna check if that key was what I just pressed. And if it is, that's what we're gonna set the index to, right? Based on this, it'll loop 1, 2, 3, 4. It matches up with the indexes of 0, 1, 2, 3, based on all of the goals, the lanes, the spawns. That was backwards there, but that's okay. So if those match up, then we will determine if we're just gonna kill it and grant points, or if there's not gonna be any points at all, depending if those match. So I believe I went over all of the blueprints in here. Yeah, I did. All right. Yeah, so that's basically how this whole entire thing works. Thank you for watching this really long and complicated explanation video.